Let's go over Module 6.3 Anatomy of a Long Bone and Module 6.4 Bone Cells. This again is for Anatomy 10A, Mount Sax Anatomy 10A, and we are using the textbook Visual Anatomy 3rd edition by Pearson Publishers. Module 6.3 is Anatomy of a Long Bone. Here we have the femur. Okay, and so a long bone, earlier module you learned the long bone's longer than it, they are wide. It describes the overall structure of the bone. And so for long bones, they have three regions. The epiphysis, which are the ends of the long bones, here and here. And then we have the diaphysis, also known as the shaft of the long bone. In between the epiphysis and the diaphysis, we have the metaphysis. So a narrow zone between the epiphysis and the diaphysis, we're going to have the metaphysis. That's the anatomy of the long bone. So the left femur shows you the bone complete, and then we have a sectional view of the femur on the right side image. Okay, and in the right side image, you can see that the long bone on the epiphysis, we have spongy bone. Looks like a sponge, trabecular bone. So here in the epiphysis, we have a medullary cavity going down the center of the bone, and then compact bone out here. That's the anatomy of a long bone. Module 6.3 also includes the vascularization of bone, and basically the take-home message for this image is that bone is highly vascularized. Okay, it's necessary for growth and maintenance. Okay, blood vessels bring in nutrients, pick up waste, and so we have lots of growth, lots of activity with bone, and so we have a high vascular need. So this would be the macroscopic anatomy of the long bone, and you don't need to memorize the names of the blood vessels. Just know that bone's highly vascularized. And this image shows you microanatomy of long bone. And so we're looking at the osteon. One of these here is an osteon, and that's the functional unit of bone. So as a review from Chapter 4, Histology, let's go over the histological structure of bone. Okay? Bone are made up of these repeating units called osteons. Each osteon has a central canal, okay, and that's where you have blood vessels coming through and nervous tissue. So we have the central canal. Surrounding the central canal, we have these concentric lamellae. Okay, so concentric lamellae is the matrix of bone. Bone is connective tissue. It's identified by cells and everything around those cells. In the case of bone, everything around the cells is hard matter. The cells are residing in structures in little cavities called lacuna, singular, lacunae, plural. And so the osteocytes are inside the lacuna. And so the dark areas here are the lacuna with individual osteocytes. Then we have little radiating lines going perpendicular to the concentric lamellae. These are canaliculi, little canals, canaliculi. So that's the histological structure of typical bone, and that's the osteon. Module 6.4, cells of bones, we know of osteocytes. Okay, osteocytes reside in lacuna. They maintain bone, but there are other cells. Cells make up from 2 to 3% of bone tissue. So these cells include osteoprogenitor cells, osteoblasts, osteocytes, which we know of, and osteoclasts. Osteoprogenitor cells are mesenchymal stem cells. They're stem cells to give rise more to themselves, and they form osteoblasts. They're found in the innermost layer of the periosteum and lining of the endosteum. So here on the left, we have the periosteum. We have two layers, the fibrous layer, which will allow for attachment of nerves and blood vessels. And then we have the cellular layer. So the cellular layer, that's where you're going to find osteoprogenitor cells as well as osteoblasts. They give rise to the osteoblast, and they're involved with their pair of bones after a break. So here is how they look in the nucleus. Here, just to really quickly, these ones are in the endosteum. The endosteum is facing the medullary cavity. Osteoblast, immature bone cells, they give rise to osteocytes, and they're very metabolically active cells. Okay, they're found in the inner and outer surfaces of bones, same area that you find the osteoprogenitor cells, and they produce osteoid. That's the unmineralized matrix, the organic material that becomes the matrix in the process of what's known as osteogenesis to form bone. So we have the osteoid that eventually will become hard mineralized tissue. Osteocytes differentiate from osteoblasts. They are the mature bone cells. Their metabolic activity decreases. There's still a lot there of life, of course, and they're maintaining the bone matrix. Okay? They maintain that protein mineral content of the matrix. They are trapped in depressions called lacunae. They do have extensions that go in through the little canals we previously discussed called the canaliculi. So these extensions in the little canals canaliculi allow for nutrients to diffuse from one cell to the other in between. Lastly, we have osteoclasts. Osteoclasts are very important removing and remodeling bone matrix. We call this resorption. Bone is continuously being remade. Okay? If you think about working out, when you work out, you're working out your muscles, and the muscles are attached to bone. Your skeletal muscles are attached to bone. And so when you're working out your muscles, the attachment points for the muscles, they're pulling on what they're attached to, which is bone. So the bone is going to be under stress, and this stress will cause the bone to develop more. And so that's where we have those projections, those features of bones. Some of those are for muscle attachment. The more you work out and work out your muscles, you're also working out, in essence, your bones. You're making them stronger, and the more bones being rebuilt, bones being resorbed and rebuilt. So that's called bone remodeling. These osteoclasts release acids and enzymes that break down bone, and this breaking down of bone is called osteolysis. This is very important also to meet your calcium, phosphorus, mineral needs on a daily basis. So if you don't take enough calcium, you have your serve in bone. So as a review, the bone tissue is composed of several different cells. Okay, we start with osteogenic cells. That's another word for osteoprogenitor cells. They give rise to osteoblasts. Osteoblasts differentiate into osteocytes. And then we have very important cells called osteoclasts, which are involved with bone resorption. Okay, that's your Module 6.4 micro lecture. Happy studying. Take care of yourselves. Bye-bye.